So we are going to take a look at that graph. So we want to graph negative 5/3 times x plus 2. So if you haven't already done this on paper, you want to do this right now. So as far as making a table goes, since, what's that? Number 11 on the worksheet. So as far as making a table goes here, since there's a 3 in the denominator of this slope multiple here, I'm going to pick multiples of 3 for x to make the graph easier. So for x, I'm going to pick negative 3, 0, and 3, and then calculate y. And so then we have a little work, so you might want to whip out a calculator. So for y, I've got negative 5/3 times negative 3 plus 2. So the point of multiplying by a multiple of 3 is the 3 is going to cancel with the denominator. So I'm going to get a negative times a negative is a positive. The 3's divide out. That's going to give me 5 plus 2, or 8. Kind of ran out of room to write that. Scoot down, down. So I get, for x equals negative 3, y equals 8. If x equals 0, well, 0 times anything is 0, plus 2, I'm going to get y equals 2. X equals 0. Equals 3, I'll have negative 5/3 times 3 plus 2. To multiply fractions, right, I view that as 3 over 1. The 3's are going to divide out because they're in opposite position. Negative times a positive is a negative. So I'm going to have negative 5 plus 2, which in this case is going to give me a negative 3. So these are the points I have to plot. Negative 3, 8, 0, 2, and 3, negative 3. Yep.
So if you just use what they gave you this type of thing,
what do you mean by use what they gave you?
Like if you just did the y, if I were to do it, so you can just apply that and got 2 points.
So by using the slope? Yeah, we're going to take a look at that too.
Is that
No, there's multiple ways to graph. But the bottom line, what does it mean to graph? It means to plot enough points so that you are confident you have the trend. So my recommendation is do more than 2 points so you're sure the trend is correct. Line tool here. How would the rest of it? Here is going to be my y-axis, my x-axis. All right, so negative 3, 8. So I'm going to say this is going, let's see, I guess I'll have to go 1, 2. So here's negative 3, and up 1, 2, 3, 4, 5, 6, 7. So I'm going to have a point about right there. 0, 2 is my next one. And then 3, negative 3. So 1, 2, 3 for x. 1, 2, 3 for y. And that's the point down there. So extra point there. So just labeling this a little bit so we know what we're looking at. You always label one axis as x and the other axis as y. That looks a little freaky today. And then I guess I'll label this as 3, negative 3, and negative 3. So that when you look at your graph later or I look at it, I know what I'm looking at. Now let's see, did your graphs already come labeled? Okay, so yours are already labeled. But if they're not, if you ever drawn it by hand, then you want to make sure you label some stuff. And then it looks like those points line up, so I'm going to try to draw a line through them. Black. Here's my line through those points. I'm just going to make a note. It continues in each direction. So if I were to plot more points, it's going to continue up that way and down this way. So usually what I do is on the graph, I put arrows on each end indicating it continues the pattern that way and it continues the pattern that way. Now, Emily mentioned using what we see in the equation without calculating points directly. So what she meant by that is the 2 here represents the y-intercept. So that tells me the y-intercept is the point at 0, 2. So I can just plot that point. And then the negative 5/3 here, that's the slope. Negative 5/3. And so this tells me my rise and my run. So a rise of negative 5 is from this point, drop down 1, 2, 3, 4, 5 units, and then run positive 1, 2, 3, which puts me right at that point that I calculated earlier. Okay, so that's using the slope. Now I can switch that. I could also call the slope 5/-3. And the reason is a negative over a positive is the same as a positive over a negative. The answer is still negative. So if I view it this way, say from that point right there, the rise is now positive 5, 1, 2, 3, 4, 5. Oh, and let's plot that point there. Oh, I can't add. So coming back here, it looks like I shouldn't have skipped a step. Let's do red. So here, the 3's are going to divide out. A negative times a negative, which is positive, and then 5. Whoa, how did I do that? Yeah, negative times a negative is positive. I just can't add. What's 5 plus 2? 7, not 8. Okay, so I misplotted that point right there. So that point should move down. All right, so from this point here, we're going to go up 1, 2, 3, 4, 5, and then over 1, 2, 3, which puts me at that point. The slope, where I calculated the points, I'm still going to get the same line. So if you do just use the slope and the y-intercept to get 2 points, like maybe this one and that one, or this one and this one, calculate one other just to be sure it's on the line. Otherwise, how do you know if you have the right line? You could have made an error with the sign, or you could have plotted the wrong number there. So it's always a good idea. So we'll go over doing these in the online system in a minute. Let's take a look at number 12. For number 12, we want to graph y equals 1/2 as the base with x as the power. Get a grid on here. So we've got y equals parentheses 1/2 to the power x. Am I on the right problem? That's good. Okay. So I'm going to make a table here. Now notice this isn't something times x plus something else. That means it's not a straight line. The points are not going to line up. So on this one, I'm going to pick -2, -1, 0, 1, and 2 for my x values, and then calculate each y value. What's that? There's room for one more point on there? All right. Let's plot these, then we'll decide on the right point. All right, so this is going to get a little bit tricky. So I'm going to start with 1 down here. If I take 1/2 and raise it to the power 1, that's not going to change anything. That's going to be just 1/2. If I I take 1/2 and I square it, that's 1/2 times 1/2, or what? Is it? Not 1, that'd be 1/2 plus 1/2. That's 1/2 times 1/2. A quarter. Yeah, this is going to be a quarter. If I take something to the power of 0, that's always 1. Power of 0 is 1. Anybody remember what negative powers mean from way back in Module 1? Flip it. Yeah, negative power means flip it. So this is going to become 2 over 1 or just 2. And then 1/2 to the power of -2. That means I have 2 things to do. I have to flip it and square it. So what's that going to do? 4, correct. So those are the points I need to plot, and then we'll decide if we need a 6th point. But I think we're probably going to be okay with 5. So start trying to plot those points, and we'll decide how to connect the dots. -2, 4, -1, 2, 0, 1, 1, 1/2, and 2, 1/4. So just kind of think of what's going to happen here. The base here is positive. So that means the answer is always going to be positive because the base is positive. Plug in positive numbers, like suppose I was to plug in 5. That would give me 1/2 to the 5th power, which is 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Right. Ask Google, what is that number? Calculator out. Oh, wrong button. So I've got parentheses 1/2 raised to the power of 5. I get 0.03. On this scale, that's kind of hard to graph that. 300ths. Okay. So what's happening here as x gets bigger, y gets closer and closer to 0. Because my denominator is getting bigger while my numerator is stuck at 1. We'll take a look at that in the spreadsheet for a minute. In a minute, sorry. Going the other direction, as I plug in bigger negative numbers, I'm flipping the base, which is going to give me a 2, and then I'm raising it to a power. So 2 to the 5th would be 32, which was way off my grid, so I can't graph it. So it's going to be hard to really fit any more points on here based on the scale getting too small this way or the numbers getting too big that way. So I'm just going to do my best to draw a curve through these points. And it does not go below the axis. And it just skyrockets up this way. Yeah, is this linear, exponential, or quadratic? This is exponential. Yeah, I'm like, yeah. All right, so the exponential graph there. Exponential graph looks like a hockey stick. Oh, you get your points backwards. So -2, 4 means -2 for x, 4 for that. Just switch direction. So we're going to try and do this on a spreadsheet. So most of you started a spreadsheet last time. If you can find it, open it up. If you can't, we'll just start a new one, or I can help you look for it later. Yeah, so last time we were playing around with the Washington population, so we're just going to make a new tab at the bottom and just add to it. So if anyone needs a hand with that, just holler, I'll come over. All right. What's that, the names for each of these? If it's a quadratic, a square in it, it makes a graph called a parabola. Exponential graph doesn't really have a special name except for an exponential graph. So we either have lines, exponentials, or parabolas. So somewhere here, 62. Yeah, this is lesson 2.7 graphing. So here we're going to graph number 12. So if you made a new tab, you could just call it 12. Last time we played around with absolute and relative changes for the Washington population. So I got a new sheet, I'm going to call it 12. So what we're going to do is we're going to make a column for X, column A, column B, we'll make a column for Y. We're going to do a little bit more than we did earlier. So we're going to start with -5 for X and then -4. Remember, once you give it a pattern, you can highlight the pattern, grab that bottom corner and fill it down. So I can have it go from -5 to 5 for X. What's that? Just for the hell of it. Yeah, so I mentioned that last time when I'm graphing. First, I just pick some numbers near 0. Unless somebody tells me to do otherwise, or I have a good reason to do otherwise. And then I plot those points and then decide if I need them. Even though we just did those. Yeah, so the ones we did are in here. Whoa, wrong button. Uh-oh, I did. That was interesting. So I got -5, I got -4. Once I type those, I highlight them and then point to the bottom corner and fill it down. Time. So basically for X, we want the integers -5 to 5, including 0. Once we get those in, we're going to do our calculation. Now I'm going to modify what it says up here for Y. So to do that, I can just double click on that cell, and then I can type Y equals parentheses 1/2 for 1/2, close parentheses, raised to the power X. So I'm just going to type in the formula we're using. It's just for looks there. I'm not sure. So to use that formula in a calculation below, I'm going to go to cell B2 once I have that. So they get that shift 6 to get that little caret. So underneath, I'm going to use it. So for the Y value related to X equals -5, I'm going to type equals. I'm going to then type parentheses 1/2 for my base. Close parentheses. Raise it, shift 6 to get the caret. And the power is just that number next to me. So just click on it. So my formula looks like equals parentheses 1/2, close parentheses, the caret, and then click on cell A2 to get the number. Once you got that, hit enter, and it should calculate the result. No, okay, don't click there. It's just wrong. Yeah, once you type that formula, you can click back on it and then fill it down, and it should do all the calculations for us. So if you're having any trouble, let me know. I'll come around and check. You good? Okay. Oh, that's Dave. Yeah, we can just grab it and move it. So highlight all those cells, that one over and down, and then point to the edge of it. Yeah, see how you get the crosshairs when you point to the edge? Yeah. Grab and drag it out. Yeah, Yeah, so now click on the 32. Look at the bottom right corner. Yeah, just a simple. Yeah, here you go. All right, let's go. You want to click on that next value. You guys right back here? All right. So again, just a couple things. Anytime we type a formula that uses a nearby number, we don't have to keep retyping the formula. All we have to do is type it once. So I'll just repeat that. So equals to do a calculation. My calculation always has a base of 1/2 with parentheses because it's a fraction, raised to the power, and then I click on the number over here to get the power. Once I have the formula, I click back on it, and then I point to the bottom right corner to get that solid little plus there, and then I click and drag that down, and then it repeats the calculation. So remember earlier we double checked what was 1/2 to the 5th power. We found it was like 3/10. So there's all of those numbers there. So we're going to have the spreadsheet try and graph these for us. Now on our papers, we only did this part of the point set. Right, so I'm just graphing a few more because the spreadsheet can do it quicker than we could by hand. All right, so to make a graph of this, I'm going to highlight all of my data. So A1 down through B12. So if you're in Google Sheets, what you'll do is in the right-hand corner, there should be a little chart button for Insert Chart. If you're using Excel, then you want to go to the Insert menu. And then from the Insert menu, you want to click from the Insert menu, you want Recommended Charts. All right, so I'm going to go to hang on those Excel users. I'll explain what to do next in a sec. So here I'm asking Google to make a chart. Now it's making a line chart, which is cool. I wanted to kind of make a line. Now notice it's not as smooth as our line was. Well, it's smoother than mine, maybe. But you guys are probably better line drawers than me. So I'm just going to, I could leave it as a line graph. That's kind of cool. That was the default here. Some things I probably want to customize on it. If I go over the Customize tab. Under Series, I believe it is. I think I can tell it to plot points too. Yeah, here it says point size none under Series. I can say, hey, throw some little points in there too. That's kind of small. All right, so for those of you in Excel, let's see. Oh, you already got yours going on. It just automatically picked that one for you? Yeah. Some usually recommended charts picks the chart you want, but every once in a while it doesn't quite do that. All right, so here's the graph. Notice it's pretty similar to what we got. Notice the scale is a lot different. And the scale is different just because we chose to go all the way up to 32. So those other points look more squashed down. Look back at, let me close this, move this out of the way. So what's going to happen as we pick bigger and bigger x values here, the y values are just going to get smaller and smaller. But because we're taking a positive number and raising it to a positive power, the answer is always going to be positive. So this graph is never going to dip below the axis. It's just going to try and get closer and closer and closer and closer and closer. I'm pretty sure on Wednesday I said the name of that behavior. Does anybody remember? It starts with an A. I might not. but I thought I might have mentioned it because this is what I wanted to name my firstborn child. Asymptote. I didn't mention that Wednesday. Oh, how could I forget that? Yeah, so I'm just going to write it down. When a curve tries to be a line, which is what's happening in this area over here, the line that it's trying to become, so in this case, this part of the x-axis, make believe that's a straight line. Having trouble drawing on this tablet today. The line that it's trying to become is called an asymptote. Asymptote. So I always thought that was a beautiful word. Before I heard that word, I was an accounting major in college, and then once I learned about asymptote, that changed my major and went into math. Because I was just so impressed with asymptotes. What's that? Ruby's probably better than asymptote. Yeah, that's what my wife thought too. She thought, no, we can't be. Because then we'll call the kid As for short, and I'll change to Ass, and it's just downhill from there. Okay, so again, this is an exponential graph. It's got that hockey stick-like shape to it here. And an exponential graph always comes from when you have a fixed base to a variable power. So if the variable is in the power position, it's an exponential function. Okay. Now, for the rest of this assignment, you have a couple of choices. You could either graph them on paper, the worksheet, or you can stick them in here. There it is. And you can do each of these graphs that you're asked to do on the computer. That one's just an example. Yeah, it's just saying, if you were to graph x squared minus 3, and you pick the points 0, 1, -1, 2, -2, and 3, then you would end up with these y values, and if you plot the points, you get this beautiful parabola type shape. Question? Yeah. Yeah. Okay, let's take a look at 13 and 14, and we're going to go back and do 11. All right, so let's do 13 off the grid, and then we'll come back and do it on the grid, on the spreadsheet, that is. I want to do it on the computer. Yeah, I want to have the computer do it too. So let me get a new tab. So we'll do 13, 14, go back and do 11. Got going this time. Come on, you can do it. You can do it. Come on. Ah! I think I'm maxing out my old computer's capabilities. I think this computer's almost as old as my younger daughter. Oh, wow. Okay, so it's x squared minus 1, is that right? Yeah. Let's get a grid in here. All right, so we're going to try and graph y equals x squared minus 1. And we'll give me a red shirt. Did this one recommend points? It didn't. So we're going to use the previous example as a guide. And here they graph 0, 1, -1, 2, -2, and 3. Now I'm going to actually put them in order because it makes me feel better. So I'm going to go for x, -2, -1, 0, 1, 2, and 3, and see what happens. For y, if I take a -2 and I square it, remember when we substitute stuff in an equation, we should put it in parentheses to be safe. That's -2 times -2, which is positive 4. 4 minus 1 on a good day is 3. When I plug in -1, -1 times 1 is 1. 1 minus 1 is 0. 0 squared is still 0. Minus 1 gives me a -1. Spreadsheet? You don't need to on the spreadsheet because when it references, for example, A2, it's essentially putting it in parentheses for you, even though you don't see it. Yeah. So I'll do that in a minute. So if I plug in 1 squared is 1, minus 1 is 0. I plug in 2, squared is 4, minus 1 is 3, and if I plug in 3, squared is 9, minus 1 is 8. So those are the points I have to graph. And I think, is the 8 off of your grid? Just a little bit off, isn't it? Yeah, they only go up to 5. Yeah, so at 3, that's going to be up by the top of the page somewhere. So that one's going to be harder to do. So now I got to try and plot those points on that grid. So give that a shot. I'll catch up here. See if I can draw better this time. I can draw straight lines today. 1, 2, 3, 4. Okay. So what do we have? So we have -2 goes with 3. -1 goes with 0. 0 goes with -1. 1 goes with 0. 2 goes with 3. And then the 3 and the 8 is off my graph. That's somewhere up here. So draw your best U-type parabola through there. It's not pointy at the bottom, it's slightly rounded. That's not bad. So there's my parabola. So this kind of equation is called a quadratic. A graph has a special name besides the graph of a quadratic. It's called a parabola. All right, what was the next one? Anybody have any questions on this one? No? Okay. 14 was 3 to the power x. Yeah, let's do this one too. Let's see. Let's do this one on the computer. So I'm going to add a new tab. Call it, was 12, 13, 14, is that what I'm on now? 14. Make my X column and my Y column. And when I usually type Y, I like to type the equation with it. So I'm going to type Y space equals space 3 caret X. So 3 to the power X. Now for X, I'm not going to go, well, yeah, we'll do the same thing as before. Let's go from, no, let's go -3 to 3. So -3, -2, and then fill that pattern down. Oops, too far. And then for the calculation, it's like before, equals. We don't need parentheses because it's just a single object for the base, just a 3. And then I can use the caret, and then I click on the X value I want right next to it. It's going to give me a crazy decimal. That's OK. And then I want to fill that down. So let's see. Cool. An easier way to do this on your computer, rather than trying to fill, because that's a problem sometimes. If you just do a Control-C on the thing you're at, use Shift and the arrow key. So I go once underneath, hold Shift, and then arrow down and highlight, and then Control-V will paste the formula everywhere. That's the same thing as doing. So the pattern's a little tricky. So here are the numbers I get. Now notice, this is kind of a flip of the graph we did before, the one after the power x. Here I have the small numbers first and the big numbers second. So next what we want to do is try to have the computer graph this for us. Now we could totally take those numbers and put them on our paper grid too, because it calculated them there for us. And I would just round. Like I would call the 0.037, call it 0.04. Right, that's close enough. Call it 0.1111, call it 0.1 about, or 0.11, something like that. To graph these on the computer, I highlight everything from A1 over and down. And then I ask the computer to insert a graph for a chart for me. Now, sometimes the computer guesses the kind of chart I want. Here, it guessed at a bar graph. I don't want a bar graph. So I'm going to change from column to, I think I'll do a regular line graph here, and then customize it with points. So in Sheets, that would be customize, series, and then up the point size from none to something else like 7. So it's kind of connecting the dots. Now it's not smooth. Ours should be smooth, but heck, it's close enough. It's all right. There is a way to make it do smoother, but I'm not so worried about that. All right, you got that on Excel. Excellent. Did you have any luck figuring it out on yours? Yeah. So I just kind of wanted to play around with making graphs on the computer. So I am going to stop here and give you guys the remaining few minutes to finish up whatever you want. As far as lesson 7 goes, the things I wanted you to graph in class the other day, last week on Tuesday and Wednesday, we played around with the data from Washington making graphs, and you can certainly hand that in with the spreadsheet. The graphs I wanted to see on the spreadsheet for sure was at 11 and 12. We just did a number 12, so you could try doing 11. We also did 14. So the procedure is the same, just you have a different equation each time. And then you'll upload that here once you're done with it. You can do all of them if you want, yeah. So instead of doing them on the worksheet, you can put them all on a spreadsheet and hand that spreadsheet in for it. Yeah. Yeah. And then next class, we're going to play around with lesson 2.8, which is going to be more making charts on the computer. We're almost done, right? We only have 3 more days after today. So we're not doing lessons 2.9 and 2.10. We're just not going to get to them. So tomorrow we'll work on lesson 2.8. We'll probably finish it tomorrow. If not, we'll finish it on Wednesday. And then the rest of Wednesday and Thursday are the review for the final. And I posted a sample final here. What day is the final? Good question. Monday. 8 o'clock. Oh, that's going to be fun. I'll bring treats, some chocolate, help us wake up. Nice and early. Thanks, Tristan. It'll be on paper. Yeah, the test is going to be on paper. There's a practice test online that you can play around with, so take a look at that soon. Otherwise, if you need any help with worksheets or charts, let me know. We'll do lesson 2.8 tomorrow. How you doing, Daisy?
Good.
Okay. Any questions for me?
No.
All right. Well, have a good day then.
You too.